Let's look a little more formally at a definition for projectile motion. Projectile motion being motion under the influence of gravity alone. Frequently ignore air resistance. So it really is a form of two-dimensional motion, sometimes referred to as parabolic motion. A ball is thrown horizontally from the roof of a 25-meter tall building and lands 30.5 meters from the base. What is the ball's, should be an apostrophe, initial speed? What is the ball's final velocity? What is the ball's final speed? So, the ball is thrown horizontally from the roof of a 25-meter tall building. So vertically, it falls 25.0 meters. In that same time, it travels horizontally at 30.5 meters. Well, vertically is all based on gravity. From the time it leaves the individual's hand, the only thing acting upon it would be gravity. So our distance under accelerated motion, now it's thrown perfectly horizontally, the initial vertical velocity is 0 because it's all horizontal. It moves 25 meters. It's a negative. Gravity is a negative 9.81. So it takes approximately 2.258 seconds for the ball to hit the ground. Horizontally, it covers a distance of 30.5 meters in that time. And it's going to be a constant speed horizontally because gravity only operates vertically. So our horizontal speed is about 13.5 meters per second. So for the ball's initial speed, it moved horizontally at 13.5 meters per second when it hit when it left the hand. Now, the final velocity, we know horizontally that's not going to change, but vertically is a different story. Vf minus Vi is equal to 2a delta y, or we could do the definition of velocity. Acceleration is Vf minus Vi over t. Either of these will work fine for finding the final velocity. Since we know the acceleration is a negative 9.81, is equal to Vf minus 0 over our time, which was 2.258. This will give us a final velocity component, vertical speed. Vf is equal to a negative 22.2 meters per second. If we had used the Vf squared minus Vi squared, forgot my squared terms. So our Vf squared is what we're looking for. Vi was 0 to acceleration. Delta y, it fell 25 meters. So we end up with Vf squared equals 490.5. So Vf is equal to 22 22.147 as opposed to 15, 22.1 meters per second. Now, again, that's just a rounding variation. But notice this does not have a sign. There is no negative here. You do have to be careful when using this combination because it will not give you the sign or the direction of the velocity component. You would have to get that by realizing that, wait, this ball is going down, so the vertical component would have to be a negative. So we can then write our final velocity as a vector as 13.5i plus a negative 22.1 or 22.2 j meters per second. Finally, the final speed is just going to be the magnitude of that. So you can use Pythagorean on this one. Square root of 13.5 squared plus a negative 22.2 squared which really is going to give us a final speed of 25.9 meters per second. A football is kicked from level ground at 22.1 meters per second at an angle of 35 degrees. How long is the ball in the air and how far downfield does it go? 22.1 meters per second at 35 degrees. We resolve it into the components. So the horizontal component is going to be 22.1 cosine of 35 degrees, and do make sure your calculator is in degree mode when you're working with degrees. And then 22.1 meters per second sine of 35 degrees, 12.68 meters per second. Now, the vertical component is what dictates how long it's going to be in the air. So vertically, we know that the initial velocity going up is 12.6. We know that the acceleration due to gravity is negative 9.81. There are multiple ways that this can be handled. The way that I typically look at it is, let's just find out how long it takes to go to the top. Because if you think about how this ball is going to travel, it's going to go up and then come back down. It's a parabola. It's that projectile motion again. The vertical velocity component at the top, vertically, that looks like VI, vertically, V equals 0. So that's what we're dealing with. So I'm going to say that the VF at the top is 0 meters per second. I just need to know how long it takes to get up there. So it takes, well, acceleration is VF minus VI over T. Negative 9.81 is equal to 0 minus 12.68 over T. So it takes about 1.31 seconds to reach the top. Now, since we're talking about something that goes all the way up and then comes all the way back down, this is a full parabolic motion from piece to piece. So the air time, that hang time, is simply 2t. So that's going to be 2.62 seconds. The reason we would use that is we're presumably on a football field since we're kicking a football. It's going to come back to the same level it started. So that means then that horizontally, distance is simply speed times time, because that's what the distance under accelerated motion reduces to when the acceleration is 0, which is what we have for the horizontal motion. We're ignoring air resistance. So the distance is simply the speed, which horizontally was 18.10 meters per second, times the time, which is 2.62 seconds. So that's going to give us a distance horizontally or downfield of about 47.5 meters. Again, 3 significant digits in gravity, 3 significant digits in our initial velocity. We're not going to worry about the angle digits because that gets a little more interesting of a discussion.